Okay, lesson 4.2 here is on impulse. It's related to momentum. It's kind of just a step further. A little confusing compared to momentum, but I think once you get your head around it, not too bad. Okay, so impulse, I, is actually just a change in momentum. We talked a little bit about that yesterday. So if we know how much the momentum changes, that's impulse. So that's one way to look at it. The other way to look at it, which is why this is confusing because there's two ways to look at it, is it's also force times time. You can think of it as, in order to change a momentum, you basically have to apply a force for a certain amount of time. In order to speed something up or slow it down, you basically have to do a force times a time. So it's really the same thing. It's impulse. So we got these two ideas that both mean impulse. That's why it's a little confusing. So here's kind of an example that will demonstrate it to you. Say we got a ball hitting a wall like we did yesterday. Okay, let's say 2 kilogram. Let's just say it's hitting a big block. It's not necessarily a wall. 2 kilogram ball going 5 meters per second, hits this wall, and it bounces back at only 4 meters per second. So basically some of the momentum is going to go into this block. Okay, is what really happened. Still 2 kilograms, obviously. Okay, so here's the questions. What is the change in momentum? What's the impulse? That's kind of questions we got to answer today. So basically find your momentum before and your momentum after. Remember, we just said, take your final minus your initial. Your final momentum, 4 times 2 is 8, right? Your initial momentum was 10. This is actually a negative, right? So this is actually a negative 8. So our total change is minus 18. Which makes sense again. It's went from 10 to negative 8. How do you get from 10 to negative 8? Well, you go down 18. So that's our delta P. So what's our impulse? Well, impulse is the same. Remember we said that's change in momentum. So your impulse is also negative 18. So you say, okay, that's kind of silly, just the same thing. All right, so that's pretty easy. Now, the other thing you'll run into is something like this. Let's do the same problem. Let's just ask a little different question. Sorry, couldn't see that. What if the force, okay, so if the impact takes, I don't know, how long would it take a ball to hit and then bounce back? Okay, in other words, the ball kind of crumples, right? And then it comes back off. If you've ever seen a golf ball hit in slow motion, you see it actually crumples a lot. It squishes down and then comes back off. So there's a certain amount of time that is in contact with the wall. Let's just say it's 0.2 seconds. That might be kind of long, but maybe it's a pretty squishy ball. Okay, if impact takes 0.2 seconds, then you say how much force. Okay, so let's do the same scenario. Just to keep it quick here. And then it bounced back at negative 4. But we're saying, hey, that during this impact, right here, it takes 0.2 seconds for it to do this change here, basically. Okay, what's the force? Well, we said the impulse was negative 18. Now we're going to use that other idea. Impulse is actually also force times the time. So impulse equals force times time. So negative 18, this is separate, kilogram meter per second equals force. I don't know the force, but I do know that happened for 0.2 seconds. So if I divide that out, what's it going to be? 5, I believe it's 90, I believe, negative 90. If you do 18 divided by 0.2, the seconds cancel, right? Nope. I could get kilogram meter per second squared, which is, if you really are on a ball, you remember kilogram meter per second squared is actually a Newton. So the force is negative 90 newtons. Okay. That's how much force is happening on that ball when it's in contact with the wall. Okay, once it's away from the wall, then okay, then force is gone. It's just, if it's in a vacuum with no gravity, there's no forces now. Okay, but there is that force going on as it hits the wall. Okay, some other questions you're going to run into. What's the impulse on the wall? Okay, what's the impulse on the wall? Well, if you think about Newton's third law, if the force on the wall is 90, if the force on the ball is 90, rather, the force on the wall is also 90. Okay, it's an action-reaction. Ball pushes on wall, wall pushes on ball. So the impulse on the wall is also negative 18. Positive 18 actually, because it's going the other direction. So it is going to be opposite sign, but same amount. The force on the wall, you might see that question. Well, that's also 90 newtons, just the opposite. So the forces are opposite, the impulses are opposite on the two objects. Is another big idea you run into. I think if you understand that, that's the basis of what you need for today. If you run into any questions, feel free to reach out to me. All right, see you guys.